How are you, my friends? Welcome back to this series, Basic Math Terms, and this is part 6 about sets, unions, intersection, complement, etc. If you need any one of these basic math terms, please go to the playlist, Basic Math Terms, in the channel, and then you can see anyone you like. Part 6 about sets. See, I found here 19 terms or words. Some of them are easy, some needs to be explained. So I will mention all of them. So this is Basic Math Terms, Part 6 about sets. Let's start. What is a set? I think everybody knows what is a set in the mind, but to write a definition in math, it's a collection of objects or collection of elements. Easy. So sets, we can have like set E, we can have a name for the set. Set E, set F, set A, set B, set C, set X, or set Y. So we can have here, if we say set E, X, Y, Z, so there are 3 elements or objects or members in this set. Set F, 1, 8, 3, 5. Now, sets have finite sets or infinite sets. Finite, see the word finite, it's a limited number. See, like set X has -2, -1 here, 0, 1, 2. So only 5 elements. Set Y has the elements 5, 6, 7 until 13. We can count these. We can find the number here limited. Infinite, we cannot count them. There are unlimited number. Like set E here, we see the number of fractions between 0 and 1. If someone asks you, how many fractions between 0 and 1? Just listen please to this question. How many fractions between 0 and 1? Now we have 1/2, 1/3, 1/7, 1/8, 3/4, 2/9, infinity. So it is not limited. Set builder notation. See, we use this to build a set. To build a set, we have a set like this one here, X, such that we read this as X, such that X has a certain property. Look at this example H here. X, such that X is a natural number between 1 and 5. See the natural numbers. You can see other videos to know what is a natural number. Natural numbers are the counting numbers starting from 1. So now we need the natural number between 1 and 5. It's only 2, 3, 4. So we use this property here to build. To build means to find, to create, to establish the set H. So it's only 2, 3, 4. These are the elements or the members in the set H. Now let's see, subset and belongs. 2 important things you have to know. But before I will tell you quickly here, what is a null set? N-U-L, a null set. Simply, it's the empty set. Like you have a class, chairs, with no students. So we say empty class, no students. So we can use phi. See here, phi, or the set is empty. But if you write a set with phi inside, this is not empty. There is a set inside the set. But when you write phi, you should write here no elements. Now, subset. Please look at these 2 together, 2 and 3. Belongs to. Subset. Just by listening, it sounds different. So subset means A is a subset of B. Every element of A is also an element of the B. So that means we are comparing 2 sets. We say A subset of B, A not subset of B. So we can compare set to a set. Now, when we say belongs to, we are comparing an element, if it is in the set or not. So X here, see the X is element. X belongs to B. We cannot say X subset of B, that's wrong. So we say X belongs to B. X does not belong to A. It's not belonging. It's not included in the A. X belongs to. So this is the math terms we are using. Intersection. Everyone know the word intersection. Intersection means the set of all elements belonging to both sets A and B at the same time. So it's equal A intersection B. We write this symbol here, the intersection. You see this symbol here. This is the intersection. This is the intersection. This is the intersection. So you have 1, 2, 3, 4, 5 symbols in this slide only. So let's see. Suppose we have A and B. See the intersection here in the middle. All the elements that are belonging to A and belonging to B at the same time. See, simple example like when you have a math class, all right? And then you have a physics class, and you have 5 students here in the middle. So 5 students are taking the same math class, they are taking the physics class, and the other students are different. So we say the intersection are 5 students. Another example here, A 1958, B 285710. Let's see the intersection here. 1 is not intersection, 9 is not intersection, 5 is there, and 8 is there. So this is A intersection B, 5 and 8. Easy. That's intersection. Now, disjoint, not easy word. Disjoint means not joint. So not joint, the sets are disjoint. That means there is no number in common, no elements in common. So A is separate and B is separate like this. Like an example here, 60, 61, 64, this is set A. Set B, 62, 63, 65, 66. If I say, find the intersection A intersection B, well, the answer will be phi empty. So take this as a rule here. If A intersection B is empty or phi, the sets A and B are called disjoint. Disjoint, that means there is no intersection. Nice word to know. Union. Union is easy. Simply, we take all the elements in A or in B, all of them. That's union. So X belongs to A or X belongs to B, that's union. See, we have to use the word or. In A or B or inside here. So we take all of them. That's A union B. Even if there is intersection or no intersection, we take all the elements. We mention them one time. Like, suppose A 1357 and B 346. Look at A union B. 1, we start here. 1, and then 3, and then 4, and then 5, and then 6, and then 7. All the elements we take, we mention that every element we mention one time. Now, suppose here we need A intersection B. 1 is not in the intersection, 3 is okay, 5 and 7. So 3, the intersection here is only 3, A intersection B. But now we are finding A union. Union. Complement, A prime. Complement, not easy word. See, the complement we read as A, we put here dash, something we say A prime. So what is A prime? The set of all elements of U that do not belong to A. Now listen, what is U? U, we call it in math universal set. What is a universal set? Universal set, it contains all the elements included in the discussion. So it is the big set in every question. It contains all the elements included in the discussion. So this is U. Now you have A all included in U. If I say find A prime, remember the word complement, C-O-M-P-L-E-M-E-N-T, complement, A prime, X such that X in U, it is in U, but not in the A, it's outside the A. So A and the complement will make the U. Now let's see an example here, 4 examples actually, 4 examples. U 1, 2, 3, 4, 5, 6, 7. So this is the big set, the universal, that's U. A 1, 3, 5, 7, B 3, 4, 6. I found here 4 questions. Be careful how to do it. A prime, what is A prime? I look here, 1, 3, 5, 7. Any element in U, not in A. So it will be the 2 and the 4 and the 6. That's it. This is A prime. Let's find B prime, please. B is 3, 4, 6. So what's left in U, not in B? That's B prime. The 1 and the 2 and the 5 and the 7. Now let's find phi prime, please. Phi prime, the empty. Empty. What will complete it? What will complete the empty? The whole U. See, phi prime is U. That's a nice rule here. You can use in the questions. Another one, U prime. What will complete the U? Nothing. U is complete by itself. So U prime is phi. Phi prime is U. Please study this. Interval, here we have to know the word interval. Interval notation, this is used in inequalities. So when we say there are 3 types of intervals, closed interval -2 to 11, open interval -infinity to 0, half open or half closed, like -4 open until 13. Remember here when we say -2, 11 or -infinity, 0, that means we are considering all the real numbers between these 2 numbers. That's interval. So it's not like 1, 2, 3, 4. Okay, it's all the numbers from -2 to 11. That means -2, -1, 0, 0.1, minus half, 3.6, 3.4, 4.1, 5.6, until we reach 11. Now, this is closed. It means what? -2 is included, 11 is included. Here, -infinity to 0. -infinity never included. 0 is not included because it is open. Now, I put here 3 examples. You have to be careful. When you have inequality, we call this inequality. We don't have equal, less than or greater than. And then you can change it to interval, or you can graph it here. So easy. X less than or equal to -1.5. See, read carefully and try to imagine. I'm telling you here, X is a number less than -1.5, less. So it goes to the left, less. So we start from where? From -infinity until we reach -1.5, closed. Why closed? Because we have equal here. That's a little trick here. If you have equal, closed. No equal here, open. Equal, closed. No equal, open. Now, plus infinity and minus infinity, always open whatever we have in the question. See here, X less than or equal to -1.5. So we go less. See? So we start from -infinity, always open -infinity until we reach -1.5 closed. Now X, look here, we start with X greater than -6, less than 7. So -6 closed, 7 open, between them. all these numbers. There are infinity of numbers between -6 and 7. This is little tricky, number 3. 3 less than x. See, how do you graph that? 3 less than x. You can rewrite it if you like. That's a little trick here. If 3 less than x means x greater than 3. Always, 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 in inequality, you can rewrite the inequality so that in the easy way to change it to interval or graphing. 3 less than x, I will say that again. 3 less than x, which means x greater than 3. So greater than 3, we start from 3. But since we have no equal here, we write open 3 to infinity. Also infinity always open. Please try to review these intervals. Let's see question number 1. Given the sets T and S, we need to find T union S. So we need to practice here on the words, basic math terms. Natural odd number. Natural odd number. You can see basic math terms about real numbers. You will find these definitions: natural number, odd number, even number. So x, such that x is a natural odd number. So it's natural and it is odd. S is y, such that y is an even number greater than or equal to 0. 0 is even, 2 is even, 4, 6, etc. And natural, starting from 1, but we need the odd numbers that cannot be divisible by 2. So 1, 3, 5, 7. If you find T union the S, see, it is the whole numbers. It's all of them, union 1, 3, 5, 7, 0, 2, 4, 6, until infinity. So it will be the set of whole numbers. This is the answer here. Simple question. Another one, let's see the words here we need. We have a U, 0, 1, 2, 3 until 8. We have A, we have B, we have D. Let's find A union B intersection D prime. So you have to apply, you have to understand the words union, intersection, complement. That's the aim of this question, is to understand the words, basic math terms. This is part 6 about sets. So try to understand the union. First find the union here, and then stay a minute, find D prime, this is D 0, 1, 7, find the complement, then find the intersection between this and the complement D prime. You can pause the video if you like for a minute, find the answer, and then we can go together and see the next slide. See, the answer you should get 2, 4, 8. Let's try it, please, and see. A union B. So I take A and B. 0, 1, see, 0, 1, 2, 4, 7, 8. 0, 1, 2, 4, 7, 8. That's union A union B. Now let's find D prime. D prime, this is D. 0, 1, 7. What will make the complement? In U, not in D. We start with 2, and then 3, and then 4, and then 5, and then 6, and then 8. That's D prime. Let's find the intersection of this and this. 0 is not the intersection, 1 is not the intersection. 2 in the intersection, yes. 4 in the intersection, and 8. So 2, 4, 8 is the answer. Let's see question number 3. Find the answer in interval notation. Also, this is a nice question to try. I give you the interval -8 to -1. This is closed, this is open. So try to know here, closed and open. Union also, we need to find the union on the graph. Open -2, closed 10. Can you do it, please? This is the last question before you see the practice. Try to draw it on the number line. Draw this one, please, and draw this one, and find the union in the answer. Write the answer in interval also. Let's see. I think you have finished now. So the final answer you should get is closed -8 to closed 10. You see all these numbers, this is the yellow. So graph this one. -8, see this is -8, closed until -1 open. So this is the graph of the first. You see the black here. Now -2, we go here, -2, open until 10 closed. Now I need union, see union all this. If I need intersection, I take only between -2 and -1 the intersection. So in the union now, I take all the elements in A, this is A, or in B, or in the intersection. So the answer will be from -8 closed until 10 closed. Now you can see practice 1, very nice question. Given the sets A, B, find the intersection and the union of the given two sets. So you have to find A intersection B, easy, but you have to know the words. See, this is the aim here, to understand the words. Union, find A union B, you can find the answer. There, practice number 2 also. Find the set E, find the set F. Check the numbers, natural numbers, prime numbers, even numbers, odd numbers in the basic math terms on real numbers. Now, are the sets disjoint? Go back and check what is the meaning of disjoint and then answer. Practice number 3, I need you to graph the first one here, graph the second one, find the intersection. I give you an example, question number 3, how to find the union. Intersection is the same way, you graph each one, and then you see the points in common, in both, in the first one and in the second one. And then the answers you can see, practice 1, 2, and 3, the answers are there. Thank you for watching. I hope I can see you in another video with another topic. Thank you very much.